All right, good morning, Kipsters. Welcome back to your favorite class in all of America. Go ahead and put your first and last name at the top. Some of you can put the greatest house in the world. Everyone else is going to put disgusting, gross, terrible, houses down. Just kidding. Not really. Okay, we're going to start off with some college notes to refresh us from yesterday. The first question says, what is the source of energy for all organisms in a food web? We learned yesterday that the source of energy for all organisms in a food web is the sun. Make sure you underline sun. Number 2, what is a producer? My 6th graders struggled with this yesterday. I don't know. Maybe they just not as smart as y'all. I don't know. But a producer is an organism that makes its own food through the process of photosynthesis. We're going to be true scholar baller shot callers and write down the 3 things that a producer needs for photosynthesis to work, which is sunlight, water, and carbon dioxide. If at any point you need to stop the video to jot things down, go ahead and do that. Question 3, what is a consumer? This is the opposite of a producer, sort of like all the good students are opposite of Jesse. Exactly. No shade, Jesse, just saying. A consumer is an organism that eats other organisms. Okay, then that brings us to question 4, which says, what are the 3 types of consumers? Well, the first one is a primary consumer, which we also call an herbivore. And this is something that only eats plants. We have a secondary consumer, which is a carnivore. Carnivore. I almost spelled it wrong. My goodness. Which is only eats meat. And then for the last one, we have a tertiary consumer. That is at the very top of the food chain. And I'm actually going to add one more, number 4, which would be an omnivore. Because a tertiary consumer can be an omnivore. So we'll just draw an arrow down. It's like 3.5. It's not really 4. It's like 3.5 or 3 part B. An omnivore eats plants and animals. All right, now my favorite one, what is a decomposer? There are 3 parts to the job of a decomposer. So the first part is that it's going to break down the remains of dead plants and animals. And as we read yesterday, it can also sometimes break down the poop. That's interesting. Yikes, kind of gross. Once it breaks down the remains of the dead plants and animals, the second part is that it is going to return nutrients or essential elements to the soil. And the last part is that these nutrients are absorbed by producers. When we say producers, we mean plants to help them grow. Okay. Last question. All food webs begin with what type of organism? Whether the food chain starts up here and has arrows going down, starts down here, has arrows going up. Every food chain begins with a producer. Alrighty. Again, if you need to pause the video to get that down, go ahead and do that because you already know, Mark, like yesterday, if anything is left blank, it's going to be your life. Alrighty. Turn the page if you are good to go. Let's take a look at the food chain here. It says, can you identify the type of organism found in this food chain? Underneath the name of the organisms, write down if the organism is a primary consumer, herbivore, carnivore, tertiary consumer, secondary consumer, producer, or decomposer. That's a lot of work. What I want you to do right now is you are going to pause the video, put your thumb up so that Ms. Talbert knows that you are being a true scholar, baller, shot caller and trying to work on this on your own first. Pause it now. Go ahead and fill those answers in. All right, ladies and gentlemen, let's take a look at the answers. So number one, we have the algae. If you said producer, excellent job. And go ahead and pat yourself on the back. Don't do that for real. That's weird. It's going to look creepy. Next one, insect. You should have written down primary consumer and herbivore. Remember, those two words are synonymous. It means they mean the same thing. We have the bluegill, which is our secondary consumer, the carnivore. And then the largemouth bass, which is at the top, is the tertiary consumer. We're going to move down to the bottom. It says use the food web below to answer the questions. One more time, you're going to use this food web, answer questions 1, 2, 3, 4, 5, and 6 underneath. Go ahead and pause the video here. Put your thumb up. Go. All right, let's take a look. So the first thing we want to do when we take a look at our food web is identify what type of players we have in the game. I'm not talking about Cam Newton and Odell Beckham. No, that's not what we're talking about. We're talking about, do we have decomposers? Do we have primary consumers, secondary consumers? It's a lot to remember, but we have to keep writing it down so that we remember what type of organisms are found in our food web. So let's take a look. Remember, food webs always start with a producer, so we know whatever's at the bottom. I don't even know if I don't know what this is, because I'm going to be honest with you. A sedge, what in the world is that? Don't matter. It's at the bottom, so we know that these are our producers. In a box this, write producer. Make your paper look like mine. That says producer. I don't want to hear. I know it's sloppy. Okay, I'll rewrite it. Okay, that's better. I can hear some of y'all complaining. Now we know that the first organisms up from the producer are primary consumers. We're just gonna write PC next to those. Bam. We know the folks that go up from the PCs are our SCs or our secondary consumers. SC, SC, SC. And we know folks that go beyond secondary consumers are tertiary consumers here and here. Okay? Now, let's take a look at the questions. Number one said, the sedges can best be described as, you should have said producer, again, because it's at the very bottom of our food web. 2, the herring can best be described as, this is a trick question. Oh, yes, I did it to you. If we take a look at our herring, I see that there's an arrow going up from the sedge, which means that the producers give energy to the herring. But, oh my goodness, there's an arrow from the grasshopper going to the herring too. What does it mean? This is a plant. This is an animal. So it means a couple things. The grasshopper is a primary consumer. There's an arrow leaving the primary consumer that we know. The herring must also be a secondary consumer. So it is both a primary consumer that eats plants and a secondary consumer that eats other consumers. So make sure you write down B and C. Number 3, the rat can best be described as, oh, I hate rats. If we look, we have our producer, primary consumer, we go up, it is a secondary consumer. Bam. Number 4, the bald eagle can best be described as, at the very top of the food chain, it is our tertiary consumer, or food web rather. And lastly, number 5, the grasshopper can best be described as, that's super simple, it's going straight up from the producers, so it is a primary consumer. Now, it says, which of the following organisms above can best be described as an omnivore? It's going to eat both plants and animals. Well, if these are only producers, that means that we need to find an organism that the arrow is going up from the producer, but there's also an arrow leaving one of the primary consumers and going to another organism. So the snail is only giving energy to the rat, but the grasshopper is giving energy to the salmon and the herring. So between the rat, herring, and salmon, we need to figure out which one of these eats both plants and animals. The only correct answer here is the herring. The herring is an omnivore because it eats both plants and animals. It eats sedges, grass, and algae, and grasshoppers. If you need to pause to get any of these answers down, go ahead and do that at this time. If not, you can go ahead and turn the page. So today's scientific question is simple. All we want to know is if we change one population or one species in a food web, how will it affect the other populations? What's going to happen? So let's take a look at our model. We're going to do the first one together, and then you are going to do the other two on your own. So here's our trigger. Here's our problem. The zoo is going to release lions into the wild. I don't know why they would do that. That sounds dangerous, but let's see what happens. So if we increase the lion population, and we know we're increasing it because it says the zoo is releasing lions into the wild, so we can assume that means more lions. Then the question becomes, what happens to our zebras? And then what happens to the grass? Well, we know that zebras give energy to lions. So if I go from one lion to like, I don't know, a billion, probably not a billion, probably like 7. Let's be for real. Then that means that there's more lions hunting the zebras. Uh-oh. Dead. Gang, gang. Got them. So this means that the zebra population is going to decrease. And the word decrease means go down. And we know that it's going to decrease because there are more lions to hunt zebras. Okay? So if our zebra population goes down because our lion population went up and there are less zebras, then y'all, what happens to the grass? If the grass gives energy to the zebras, which means that the zebras is eating the grass, but we have fewer zebras, then that means that the grass population is going to go up. And the reason for that is because if the lions kill the zebras, then the grass does not have as many zebras gnawing on it, eating it. So now the grass is like, turn up, turn up, turn up, because it can grow because there's not as many predators or zebras eating it. So because we have fewer zebras eating grass, it's all the lions' fault, greedy lions. Now let's do one more together, and I'll have you do the last one on your own. So now the zebras are dying from a disease. Oh my goodness, the poor zebras, that's so sad. So if the zebra population, remember it says they're dying, so that means that the population is going to go down. So we'll say decreases. We'll draw an arrow down to remember that. Okay, so we'll say bye-bye. Then the lion population will, let's try to figure this out together. Zebras are dying, so there's less zebras. If lions eat the zebras and now they don't have as much to eat, think about it. Like if you go to Popeyes and it's like a 5 chicken finger box, and now it's only 1 chicken finger in the box that they selling, you're going to be hungry and upset. So now instead of a 5 zebra piece meal, he only got a 1 zebra piece meal. Guys, our lions are going to die because they don't have enough food. Now I'm hungry. I want some Popeyes. So then the lion population will decrease because there are less zebras in the ecosystem. Okay? Now, what happens to the grass? So remember, we have less zebras. So if we have less zebras that are eating the grass, that means that our grass population is going to go up. So the grass population will increase because there are less zebras eating grass. Awesome. So grass goes up, zebras goes down, and lions go down. All right, guys, you're going to try this last one on your own. Good luck. I know you can do it. Some of y'all can do it. I don't know about everybody. But pause the video here, put your thumb up so Miss Talbert knows you're working. So. All right, Barbara, let's see how you did. So the trigger here, it says wildfires burn huge areas of grass. So just for clarity, a wildfire means there's fire, it's running wild, it's going everywhere. Okay, so you're with me. So if the grass population decreases, because remember that fire is going to scorch the earth, it's going to burn those grasses, so all that's going to be left really is dirt, then the zebra population will decrease, because the zebras running around like, oh my gosh, what's the grass? No grass left, because they have less food to eat. Now, this means that grass went down, zebras went down. What do you think is going to happen to the lions? You guessed it, lion population is also going to decrease because the zebras have either died out or moved, because remember, they don't have anything to eat. But because of that, the lions have less to eat, and they will also most likely die out. Okay? But if our producers get this right, it means that everything else in the food chain, populations will always decrease. Okay? If you need to pause this to write down the answers or rewind, go ahead and do that. If you're still with me hanging on, then go ahead and turn the page. Now, what you're going to do is evidence I have two. See how I made that rhyme there? That was cool. You're going to put a thumbs up here. I want you to work independently to try to figure this one out. I know you've got it. You're going to answer questions 1 through 6 on your own. And then you're going to move to the back and answer the main idea. The main idea question says, how does the loss of a predator affect the animal populations? So how does the loss of one of these animals that eats another animal affect some of the other populations? That's what it's asking you. All right, go ahead and pause the video right here. You're trying on your own. Yes, I'm talking to you. I can see you. I'm literally living inside the computer. Don't make me snitch on you. Okay, here we go. Pause the video here. Go. All right, y'all. So to show you what happens in a food web, sorry, that was my elbow. My bad. All right, here we go. I'm going to take a look at this simulator. So what we have here, this energy pyramid represents an ecosystem. So we have a couple of different organisms. We have our grass on the bottom, rabbits, snakes, eek, and a hawk. So let's see what happens when all of these things are living in harmony. You see there's pretty much a balance. But let's see what happens if I increase the amount of snakes. Let's pause it. If I increase the amount of snakes, immediately you see the rabbit population decreases. Now, what we notice is that when the rabbit population decreases to its lowest point, all of a sudden the snake population plummets. That means it drops really fast. And the reason for that is because the snakes have overeaten and now they don't have anything to eat. Let's reset this and try it again. So normal ecosystem, let's take away the rabbits. Pause it. So again, if we decrease the rabbits, immediately the grass population shoots up. But we see a decrease in the snake population, which causes a decrease in the hawk population. Let's try it again. This time we're going to go for the tertiary consumer, the hawk. So a normal ecosystem, let's add a few hawks. Boom. Again, you add the hawk, the rabbit population goes up because the snake population went down. Now let's talk about the grass. If we increase the grass, immediately rabbits go up, snakes go up, hawks kind of stay the same. But then all of a sudden there's a sharp drop in the grass because, of course, with more food to eat, you want to eat more. The rabbits overate. Let's keep watching and see what happens. So as you can see, the ecosystem on its own stays pretty stable. Once animals overeat or if something happens, there may be an initial sharp change, but over time, and you can even see here, over a few months, things will stabilize and the ecosystem will be back in harmony. Now, let's take a look at our responses. Number 1, what is the ultimate source of energy for all life on Earth? The sun. What is an example of a producer in the food web? The aquatic plants. You could have also said the terrestrial plants. What are the 2 top predators of this ecosystem? Top dogs here are the hawk and the owl. If hawk poachers, and these are like hunters that actually hunt illegally, shame on you, killed off the hawk population, so if we have no more hawks, we'll cross them out. Bye bye. Bye. Wave a little hand. Alrighty. So if the hawk population is killed off, what would happen to the rat population? So we say the rat population will increase, and that's actually all you need to say. And it says, explain your answer to question 4. Because the hawk has been removed, the owl only has to worry about one predator. Ooh, and we need to revise that. Because the hawk has been removed, we should say the rat only has to worry about one predator. So what's going to happen is that our rat population is going to go up because before there were 2 different organisms hunting the rat. Now it's only one. So the rat is putting on his party shoes. He is tap dancing. He is excited. His population is going to go up. But just like we saw in that simulator, there's going to be a whole lot of rats. These represent all of our rats. And because there's more rats, then there's going to be a whole lot of owls. And eventually the owls are going to overeat and they're going to take away their own food supply. And that's going to cause the owls to then die, and then eventually they'll stabilize again. So if the rat population increased, what would happen to the owl population and why? If the rat population increased, then the owl population would also increase. The owl population would increase because there's more food for their population to eat. Now here's the kicker. As the owl population continued to increase, it would most likely start to overhunt or overeat, causing the rat population to decrease again. So now you're doing the main idea question, which is, how does the loss of a predator affect the other animal populations? I'm going to give you some help here. So let's say, for example, that the sparrow is killed by a disease. Tell me, how does the loss of the sparrow impact the food web? So how, you want to write this question down. How does the loss of the sparrow impact the food web? Take 2 minutes on your own to answer that question. This is the last question for our worksheet. When you're done, you're going to hold up a fist so Ms. Talbert can check your work. Excellent job today, 5th grade. I love you guys way more than the 6th graders. Don't tell them that because I'm going to lie and say that you're lying. Okay, love you. Bye.